Good evening from my side as well. I'm going to speak. You need a paper towel or something. I'm going to speak about algorithmic trading. I'm going to start with a very short introduction of my person, just to save some time since it's already 8:45. I could list all of the positions where I worked in. The main point is I've never studied something regarding IT, so I was 14 when I started, and I always wanted to play video games. And I'm from a very small village, and then I noticed, okay, my internet connection is too bad, and then I decided, okay, instead of playing video games, I would like to program my own video game. And afterwards, I got some more or less skills in Java, and then I decided, okay, I would like to use my skills to actually earn some money with it. Since you could imagine, if my internet connection was too bad to play video games, there weren't a lot of jobs in my village to actually earn some money over them. So I decided, okay, you're going to program something which will earn money for you. And therefore I decided, okay, I'm going to write a program which is trading different securities, so shares or cryptocurrencies for me. That said, I have to do a little disclaimer. Since I'm currently working at Erste Bank, I have to say that everything which you see now is no investment advice at all, and this is my personal opinion and does not necessarily have to be the opinion of Erste Bank. That said, okay, so short introduction, what is algorithmic trading? In general, it's like an approach where we have computers which automatically trade all kinds of securities for you. So as I mentioned, it could be shares, could be cryptocurrencies, it could be even be resources. And the objective is to profit from short-term price movements in a way that we buy when resources or the securities are cheap, and we sell them when the price is raised. In general, there's like, how does that work? So first of all, we need to have some data. So we collect financial data and analyze it a little bit. And when we know what kind of data we have, what we can work with, we can come up with a strategy. I'll show you a strategy later on, but assuming that you already have a strategy, you can backtest it and optimize it. So if you have an idea, you can think about, okay, what would be the performance of the strategy measured in the returns, or how much money you earned in the past. Then there are three other parts. So in general, you need technical infrastructure to run that. Normally, you have an advantage if you're closer, for example, to the stock exchange, because your latency is reduced, and there's this area of high frequency trading where the programs are executed that fast that there are milliseconds where these securities are traded. This is a highly regulated area as well, so the authorities tell you a lot. Okay, you have to, I don't know, implement some security measures and have to report a lot of things to them. But I'm here to speak about how this is implemented in programming, and there are mainly two approaches for that. The first one are static rules. This is what I will start with and explain to you how a strategy can look. And the other one are machine learning approaches, where we actually train some machine learning models to do so. There is one main point about that: the performance of both approaches changes over time. So this is when the market changes, so the market behaves differently depending on several economical factors, and therefore you need to adapt your strategy over time. So normally when you get data, I've written my program in Python, and it's quite easy to get financial data. What we see here is like the prices of the Apple share in the period from 2020 to now, and we see that we just get a data frame containing a lot of rows, and from there we get actually our financial data, which we can use to build our strategy on or to train our machine learning model. Sometimes it makes sense to not only use price data, but you can also calculate some technical indicators. This is just some mathematical calculations based on the historical price and on the volume data. And there's several of them. So for example, moving averages, which I will use to show you a strategy later on in this presentation, but there are also other ones like the volatility, which is the financial term for the standard deviation. Then there's the relative strength index, the MACD, which is moving average, convergence, divergence, and there are many more. So you can use all of them. I know it's late in the evening, but in the financial world we actually need some mathematics. This is just the formula for how to calculate a moving average. And this is extremely easy to do in Python. So what we see here or down here is the way how to implement that in Python. The moving average is calculated, you calculate the average over a certain period of time, and then you move one time step further. So for the calculation, you use one, or the oldest price will drop off and the newest price will drop in, and therefore you have a moving average. You'll see later on how that looks. Actually, you see here how that looks. This is the graph, so what we see here in blue is actually the share price of the Apple share, and this white dashed line is the moving average over the last 50 days. And what we can do with that is we can develop a very easy strategy. So for example, we decide when the Apple share price reaches or gets higher than the moving average of the last 50 days, we decide, okay, we will buy here. And if it's the other way around, if the share price drops below the moving average, we will sell it. What we can do then is we can write as a program, which is telling us all the different points in time where we actually buy the share and when we sell that, and that's what we see here. So the green points is when we buy the shares, and the red ones is when we sell the shares again. I've mentioned backtesting shortly before, so what we can do now is we can think about, okay, how much money would we have earned if we would follow this strategy over the last 3 years? And what you can see here in the middle is if you would have an initial investment of 100 euros or $100 in the Apple share, we would end up with something like around about $170 at the end. And down here we can see whether our trade was positive, these are the green bars, or the trade was negative, so we actually lost money due to following our strategy. Especially interesting is it when you compare your strategy to the strategy where you just buy the share at the beginning and hold it to the end, which is also known as buy and hold. And what we can see here is that our strategy underperformed the buy and hold strategy. So with our strategy, we would have like a return of 81, around about 81%. And if we would just have bought the Apple share at the beginning, we would end up with a return of around about 150%. So it was not an advantage for us to use our strategy, and the optimization of the strategy comes into the game. That's what I just mentioned. So the goal of the optimization is that we achieve a higher return than this buy and hold strategy. And when it comes to this special strategy where we have this moving average, we have exactly one parameter which we can change, and this is the number of days on which the moving average is calculated. So for this example, I used 50 days, but we could also use 20 days, 30 days, or whatever. So to optimize the strategy, we just run our program again, but with all possible days we can think of. So what I've shown here are is the return of the different strategies, starting with a calculation period of the moving average of 2 days and moving on to 200 days. And what we can see here, marked in green, is the strategy which returned us most of the money, which is, or ended up with a return of around about 260% at the end. And if we compare that to the buy and hold strategy, we can see we actually outperformed the strategy, so we ended up having more money in the end than if we just would have bought the Apple share at the beginning and would hold it until the end. This is a static rule, so we are always buying and selling depending on the moving average. And what we can also do is we could train machine learning models. So there are various models which you can use, like linear regression, decision trees, neural networks, but I won't go too deep into them and explain how every of these models is working, since this is a little bit out of scope for this speech. All of these models are trained in the same way. So you use this price data and just technical indicators, which I have calculated before, to minimize the difference between the predicted value, so the predicted share price, and the actual share price which came out. And using that, you train your models. And if you do that, so I trained an XG boost model here, which is a tree model or random forest. And we can see, or we can notice two things. The first one is we executed a lot more trades than before, which summed up to almost 340. In comparison, it was around about 20 before using our moving average strategy. The second point, which we can see here, so in blue we have again the return of the buy and hold strategy, the white dashed line is the money which would be returned us from the XG boost model. And please notice that this is a second axis, and we would have ended up with around about 3,500 euros using an initial investment of 100 euros. There are several limitations, especially when it comes to the charts which I just show you. So the first one, the model or the data wasn't split up. Normally you use a training data set and a test data set. In this case, I only used the training data set, so all of the data was known to the model, and therefore it was quite easy for it to predict the value. As soon as there's new data available, for example, when the market behavior changed, the model must be retrained or should be retrained as often as possible, just that the model keeps up with the dynamics of the markets. Since we executed 340 trades, normally you have to pay a fee on stock exchanges to execute a trade, and this chart, which I have shown to you, does not include trading fees, which are, depending on the time frame, a very significant point. And as I mentioned before, so markets are very dynamic and they're subject to constant change. So results which were shown in the past cannot always be extrapolated to the future. And you, for example, if there's like the Corona crisis or anything else, there could be like shocks or huge events which has an impact on that. So actually back to programming, after you have some kind of idea what I'm doing. I'm currently building a website where you can either use a pre-trained model, which I provide, or you can train your own model. And no. Yep, I just noticed this as well. There we go.
No.
Brilliant. So what you can see here is like the main page of my website. I started this project 7 or 8 times. Since I mentioned I haven't studied anything regarding IT, and therefore I always learned new things, and I weren't happy about the results before, so I decided, okay, I start again. Without showing you all of the text which is written here, which is more or less not that important, we can go directly to this page here, and here are all the bots which were created are shown. And before this event started, I actually created a linear regression bot, which is more or less the simplest one, and I gave it simulated 100 bitcoins. And what we can see here in the time, so it was trained at around about half past 6, and we can see it executed a little bit more than 60 trades in this time. And we actually had a positive return in this time period of about 0.18%. Or in other words, we would have earned 0.18 Bitcoin if it started with 100 Bitcoins. And I could stop the bot here again. I can create other bots, use different type of models for that. And the ultimate goal is that you can either train your own model, so you can choose which technical indicators, which features should be used, and then backtest it and deploy it or let it run over this website, and actually earn some money with it. Or if you have no idea when it comes to designing a model or having a strategy which should be implemented, you can choose pre-trained model to provide on this website. That is all which I would like to show you. We have 9 o'clock, and I would say that is a good ending, and I'm happy to answer your questions now. Yep.
So let's say I take one of your models and I choose arbitrarily a coin, a cryptocurrency.
Mm-hmm.
There are several reasons why which one performs, why one would constantly go up or stay constant or totally fluctuate. Does it then relearn on the new behavior of the currency, or does it do I take a package that has learned on a certain currency that would not work for another currency?
You would have a model which learned for a certain currency. So this was actually the topic where I wrote my bachelor thesis about, whether you can use the same model for different kind of shares, securities, or whatever. And it turned out you just can't, because normally the models are not too good in doing this thing. It's enough that they do some positive returns, but especially when it comes to short time frames, it's more or less like flipping a coin, and therefore you need this automatic retraining, which is done on a regular basis. So, for example, every minute or every 5 minutes, or whenever there's noticed that some shock occurred. So when the price drops 5% within a minute, you should probably retrain your model.
Okay, and so you said it's now 60 times in about 2 hours, right?
Exactly, yeah.
So is this dependent on the fluctuation or dependent on time?
How often trades are executed? I cannot tell you why the model does that, because you could calculate it by yourself, but especially when you use neural networks, there are a million or even a billion weights which are producing the output, and therefore I can't exactly tell you why the model thinks it should do that. What it's doing under the hood for the next time step, in this case it's running on a time frame of 15 seconds, it's predicting if the next price is higher than the current price. And if that is the case, it would buy. And if it's called a long position, so if you already buy the security and the model thinks that the price will drop, it will sell the security. And that's the idea behind it.
So if I see the several models on your page, it would say this is Bitcoin model, this is a...
Yeah, so at the moment, I provide data for 5 different cryptocurrencies. So we have Bitcoin, we have Ethereum, then there's something else called Luna too. There's the Binance coin, and there's Ripple. So you can choose one of these 5 securities, but this is only limited due to the broker which I'm using, because I can't trade directly at the exchange. I need some man in the middle, if you would like to phrase it in this way, who's actually executing the trades for me, and I'm just doing an API call to them and telling them, please buy it now, or please sell it now.
And are you showing the performance of each one by having one model running the whole time to see how it's...
This is the goal, but since I'm at the beginning of this project, I'll do it later. I'm just working on a graph where all these trades are shown, and there is a version of it, but when I tried it out before, it failed, and therefore I decided, okay, I comment it out. You can even see the price chart updating here. It doesn't look too nice. I'm not a front-end engineer like Sean over there.
Thank you.
You're welcome.
Yeah, I got a question. So, for the inputs, are there any similar bots that take into account sentiment analysis of news?
I actually tried that out. I mean, the time frame is quite too short. Trading on the time frame of 15 seconds, there are too less news that it would make sense to include it into that. But I had a project where I tried to predict the share price in 2 weeks based on the ratings which analysts from different banks give, and the accuracy of that. I tried to predict whether the stock is going up or stock is going down, and the accuracy of that was 50%. So you could flip a coin and then decide to buy or to sell it. Wasn't too good.
Okay. Another question.
Yeah.
Front end. What do you do?
So what I did is I took a free HTML template
Nice.
and changed all of the text, the functionalities to it. I would say I can help myself when it comes to JavaScript, CSS, HTML, but I'm not good at it, not at all. And therefore I needed some template which I just adjusted to my needs. And
But you wrote like the bot, like the
Yes, yeah, exactly. So
Yeah.
I did that, but all of these aesthetics here were provided by this template,
Yeah.
which you can
Nice
also
template.
see here. So there's demo@gmail.com or readable content of a page when looking at it, and yeah.
It looks good though.
Therefore, I just decided to save time and take a free template and
Yeah.
then just adjust it.
For sure, it looks good. Thanks.
Let's have one last question.
So I didn't quite understand. So say I have some Python code which I think might work. So what would the algorithm be to connect it to that website? So is there some API or do I plug it somewhere or like how does it work?
When you write Python code,
Yes. So say I have some.
that would be an idea to implement. Currently, the idea is that I'll provide a web page where you can just click all of these things. So, like,
I mean, a couple of web pages probably would work well enough. Yeah, thank you.
okay.
Thank you.
You're welcome.